Hi there, and welcome to the ITCZ Explained. This is part 2 of 2 clips, the first of which described the movement of the ITCZ, and this one that deals with the explanatory half of this question. Essentially what you're being asked to do here is to explain why rainfall levels vary as we move north from location C at the coastline of West Africa, inland, past location B, towards location A. Okay, so let's get started. First of all, we have the ITCZ. Now, in January, or springtime, the ITCZ will be moving over location C. When that happens, it will bring the tropical maritime air mass with it from the Gulf of Guinea. The ITCZ is where the overhead sun is beating down on the Earth, creating an area of intense heating. It heats the air and causes it to rise. We can call this low pressure air. So where the tropical maritime air mass rushes in over the Gulf of Guinea, bringing moisture with it, it gets heated at the ITCZ and therefore rises up. The same can be said for the tropical continental air masses of North Africa passing over the desert. They are therefore dry. Where they meet the overhead sun, they both get heated up, they both rise up into the sky. The moisture within the tropical maritime air mass gets condensed as it rises and turns into large cumulonimbus clouds, leading to very heavy rainfall. In the graph that's just appeared, you can see that as the ITCZ passes overhead in January, February, March, levels of rainfall go up very, very quickly indeed. You can imagine now, as the ITCZ continues on its journey northwards as the months roll by, it's going to take that band of cloud you see on the left of your screen with it, and that's why the amount of rainfall drops. We'll deal with this second peak of rainfall later. So far what we've described are two air masses meeting at the ITCZ. Here, the overhead sun heats them, causes moist air to rise, which causes cumulonimbus clouds and heavy rain at Lagos. Okay. The ITCZ has now moved north. What we're dealing with here are the months between January and July, approximately. As you can see by the size of the cloud on the left of your screen, the amount of rainfall has diminished. It's got less. This is because the tropical maritime air mass has had to pass over land. Its source of fuel, if you like, its source of moisture, the Gulf of Guinea, is more distant, and therefore there is less water to be evaporated up into the air, condensed, and then condensed into clouds. Also, it has dropped most of its moisture in the form of precipitation. So you can say that location B, in this instance we'll call this Jos, does have a peak of rainfall in around June, July as the ITCZ passes overhead, but up until this point it's had quite a lot of dry months, because up until this time location B has been covered by tropical continental air masses that lack moisture. So your marks here can be scored by saying, when the ITCZ arrives, it does bring rain, however not as much rain as in Lagos because the tropical maritime air mass has lost a lot of its moisture. And you can say that Jos has much less rainfall for the other months of the year because it is at those times covered by the tropical continental air mass, which is a dry air mass. Now we're in July and the ITCZ has moved further north and is now over location A. Notice that the amount of rain now is very small indeed. This is likely to be a location such as Timbuktu. And you would say here that the peak of rainfall is very small because the TM air mass, the tropical maritime air mass, has had to travel a great distance and has passed over much of landlocked desert Africa and has therefore lost a huge amount of its moisture, so very little rain falls. Now, what many candidates then miss is that the ITCZ returns south. As it does so, let's go back to looking at Jos, but I'd like you to keep Timbuktu in mind. As it does so, it starts to absorb, the tropical maritime air mass starts to absorb some moisture from the Gulf of Guinea again. And so a slight increase in rainfall can be recorded. But more importantly, this means that tropical continental air masses are dragged back down across Africa. And this explains, if I go back 2 steps here, this explains the drought that we see recorded in Timbuktu in October, November, December. Because during those months, the tropical continental air masses are being pulled back down over Africa, bringing drought conditions. We're now in December, and we're basically back to the beginning. The ITCZ is back over the coastline, the tropical maritime air mass can absorb huge amounts of moisture again, and the overhead sun is heating that area to a greater degree, and so large amounts of moisture are being evaporated up, and causing huge cumulonimbus clouds, causing high levels of rain, and that explains the peak of rainfall that you see in the later months of the year in Lagos. The second peak can be explained. Okay, you want to review this clip, pausing it at each section. I would recommend pausing when the graphs pop up on the screen, and perhaps try reviewing the clip with the sound off and see if you can explain it as the images appear. If you have any problems with this, come and find me. And as long as you break it down into simple sections, really this question shouldn't present you with any difficulties at all. Just remember, in the description section, use data, quote data from the graphs and maps, and in the explanation section, break your answer down into location C, B, A, and then returning A, B, and C as the ITCZ moves north and then returns south. Refer to the tropical maritime air mass bringing moisture, and refer to the tropical continental air mass bringing drought conditions. If you can explain some detail as to why, for example, the lower pressure air rising to form cumulonimbus clouds, or the fact that the tropical continental air mass passes over desert, therefore absorbs no moisture, then that will enhance your answer. Okay, I hope that's helped you, and as I say, come and find me with any questions.